For some of you, this is going to be a big time review. We have to review some binary number systems. Binary number systems help us in lots of different ways, and I did this in class, but we're just going to start with what we know, decimal. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. In decimal, that's all we know. If I were to ask you how high you can count, kind of a stupid question, I would suggest that you don't know how to count higher than 9. After that point, it starts repeating. We haven't thought about that in a long time. But 9 is our terminal character. So after this, if we add 1 to 9, 9 is going to turn into a 0, and we're going to carry a 1. And that's the same with all number systems. So if we start up here and we do binary, I'm just going to do 3 digits. Okay? 3 digits of binary. 1 is now our terminal character in binary. So now we have 0, 0, 1, which makes a lot of sense. This one turns into 0, 1, 0. If you want an explanation for that, we have 0, 0, 1 plus 1. And this is going to turn into a 0. We carry a 1, and we're done. So it works out, the same math kind of works out as before. If we add 1 to this one to get 3, 0, 1, 1. Okay, and then this one we'll do again over here on the side, making sure my recording level is out here. Okay, so this is 0, 1, 1 plus, I'm just going to put 0, 0, 1 just to keep consistent. That's going to carry to a 1. 1 plus 1 is 0, and then we carry, and so that should give us 1, 0, 0. That makes sense because for the first 2 digits, there were no other possible combinations. We did all four different possible combinations. 1, 0, 1 is 5. 1, 1, 0 is 6. 1, 1, 1 is 7. If we wanted to go on to 8, we'd have to add in another digit. And now time to make sure that we fully understand the pattern that's going on here. 0, 1, 0, 1, 0, 1, 0, 1. Odds have a 1, evens have a 0. Okay? If we go to the next column, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, forever and ever. Just 2 zeros, 2 ones. 4 zeros, 4 ones, 4 zeros, 4 ones. Same happens in decimal, by the way, 0 through 9, 0 through 9, 0 through 9. It keeps on repeating forever. And then we also, we'll go 8 zeros, 8 ones. And then we'll go 16, and then 32. Those are all powers of 2. You can do the powers of 2. 0 to the first is 2, 4, 8, 16. I guess it would start off at 1, right? 1, 2, 4, 8, 16, 32, 64, 128. These should sound familiar. 256, 5, 12, 10, 24, 20, 48, 40, 96, etc., etc. And so some of these numbers should come through. 512 comes to mind. 512 megabytes of RAM back when that was a lot of RAM. So we use that to index we use those numbers. There's reasons. It's because we're using ones and zeros to address the space, to address this part that's going on there. Okay, so now that we're done with all of this, zeros and ones are awful for us to read. And let me give you an example. I can 1 0 0 1 0 1 0 1 0. Okay, you've seen it. Now tell me what it is, and you won't be able to remember. And so we have 2 forms of shorthand for this. One is that we can block these up into groups of 3 bits. And we'll just throw a 0 out here. Okay, we call this octal. And funny enough, from here to here defines octal. Okay, and so if we look at this first one, that's a 6. Second one is a 2 and a 2. So this would be an octal 226. Nobody uses octal. Okay, maybe some people do, but the typical way that we do is we block them into groups of 4. And that's kind of but we could remember 226. You couldn't remember the binary, but you could remember the octal. So that gives us a little bit of idea of why we want to do this. What we do is hexadecimal, and what happens in hexadecimal is after 9, we add characters. all the way to F. This being 15 on 9 through 15, and we can put the binary over here as well. So, and you can go through and verify that my pattern's right. 0, 0, 0, 0, 1, 1, 1, 1, 0, 1, 1, 0, 0, 1, 1, and I'm all ones. Okay? And so this is octal. We denote octal with the 0x, and if we break out these 4 bits, that's a 0, 1, 1, 0. And so if I add my zeros over here so it's more easily recognizable, okay, 0, 1, 1, 0, that's a 6. And the lesser significant nibble, we call 4 bits a nibble. And then 1001, that's a 9, 96. And so we tend to look at binary numbers. So this is shorthand. If I were to cover this up and tell me what it is, you'd say 0x96. Yeah, 0x96. You wouldn't forget. This one, we've already forgotten. You couldn't tell me what it is for the life of you right now unless you have photographic memory. But if I give it to you in this format, we can remember. It's one of those techniques. So you end up using hexadecimal quite a bit. Octal, not so much. Binary, we use when we're actually at the root level. And so this is our introduction here to just really basic binary numbers. We haven't done conversions between different systems very much. We did from binary to hex and octal. And we should be able to go from octal to binary, but decimal to one of the binary systems is more challenging, and we'll show you how to do that another time. Right now, we're only interested in octal or hex, and this also in most codes a 0x, so that's a 0, not an O. Okay, 0x96 is going to be that's a hexadecimal value. And the 0x denotes that in most modern languages.